Uh, I'm Ryan Trinkle. This is John Erickson. We've worked together for a long time in the Nix community. Nix really made a huge impact on how we work. I started moving stuff to it in 2012. And that was in the context of a company that wanted to provide a really high quality SaaS application to some commercial market. So obviously one of the most important things about running a high quality application is knowing that it's actually high quality. And how do you determine that when you're constantly changing it? Well, continuous integration is sort of the main and first step for most organizations in that. I'm sure probably almost all of you know what continuous integration is, but I'll just reiterate it in case. Basically, continuous integration is a system that continuously builds and tests your software as people make changes so that you always know whether what you've got on your main branch is something you can actually push to production. And it can enforce all kinds of other rules, and sometimes they do automatic deployments and all kinds of other automation. But basically, you want to know that the work that you've been doing, the work that you continue to do, continues to meet the quality standards within the company, and CI is the framework for that. Now, Nix gives us an amazing foundation for this because Nix gives us a very high degree of reproducibility. So with a lot of non-Nix-based continuous integration systems, even if CI says your code is good, it might not be good because the thing you put in production might not be the same thing that your CI system tested. That's no good. And so obviously people have ways that they try to approach this, like using Docker containers or really carefully holding on to artifacts that the CI system produces and making sure those are the things that get pushed to production. There are many ways to do these things, but Nix gives you the advantage that the default and kind of only way is already pretty good. You don't have to really reinforce it at any given step. Now that being said, Nix is not really that great to use with traditional continuous integration systems for a couple of reasons. Let's see. I'm going to skip ahead to this one. The two big reasons basically being that Nix is based around sandboxing everything and having an absolute total chain of custody for everything that your software depends on, which often is a lot of stuff, right? So when we build, at our company, we do a lot of Haskell work, and the Haskell compiler toolchain is like a few gigabytes. And so when you try to go build stuff in a traditional CI, well, it needs to fetch all that stuff. And every CI system tends to have its own caching stuff. They all tend to be not as principled as Nix. They tend to not interoperate with Nix super well. So people who use Nix, the long and short of it is we tend to use Nix-oriented continuous integration solutions. I'm going to go back and talk a little bit about the benefits of CI. I already mentioned testing, but the other big one with Nix is that Nix, in addition to doing reproducibility and all the sort of robustness things that we like, it also has this awesome caching capability, which, whereas outside the Nix community, you might pull Docker images with Docker Compose or whatever, but then as soon as you make a tiny change, the whole thing has to rebuild from scratch. With Nix, you can have very fine-grained binary caching. And so if you have a bunch of different people on your team, they're using a bunch of stuff, you can pull from binary caches, and everybody's development environment can be set up very, very quickly. I mean, when I converted my 2 companies ago from like Ubuntu and just traditional stuff to using Nix, we went from having usually a few days to a week for a new developer to set up their laptop to 10 minutes, however long it takes to download, basically. So that's another huge advantage. And that's another place where the traditional CIs, even if they have their own internal caching, that cache is not usually exposed to developers to be able to pull it directly onto their laptops. So we want to have Nix solutions to take full advantage of Nix and also to deal with the sort of different performance profile that Nix has from traditional builds. And so we have a few different tools in the marketplace here. I've only covered the ones here that are well known and publicly available for some time and sort of tried and true. There are a whole bunch more. There, if you go look on the discourse, you're going to find more. It's a great open source community. Lots of people do this kind of stuff. So Hydra is probably the best known CI solution in the Nix space. That's the one that builds Nix packages. So anytime you're seeing whether a given version of something is building on Nix packages or whatever, you might find yourself on hydra.nixos.org, and that is that. And this is an open source project you can use yourself. In my experience, people find it kind of difficult to run, difficult to keep running. It tends to be, it has every feature pretty much that you could imagine, but it's kind of a beast to work with. Hercules is probably the best known, most mature managed CI service for Nix. So Hercules will manage the actual interfacing with your GitHub project. It will manage assigning jobs out, and it will give you a user interface for all of this. With Hercules, you do run the actual builds on your own hardware, which is nice. It also is a thing that you need to set up. Garnix is a little bit less, at least it's a little younger. I guess I don't really want to comment on exactly how mature each of these solutions is, since they are competitors with each other. But I think that Garnix is a newer competitor, and they host the runners for you as well. So they'll manage not only the build, but also getting the machines ready to actually build the software. And then we have some more specialized tools. So there's Cachix, which is just for caching, and also has some deployment features, but it's focused on caching, as the name implies. And then you've got nixbuild.net, which is effectively like a remote builder as a service. As far as I know, they don't do anything with the actual CI sort of traditional loop, but they'll give you as much compute as you need on demand. So that's the basic lay of the land here. Of course, there are other tools, and I'm not discouraging you from using any of those, but these are the ones that seem to me to make sense to say, like, this is the normal stuff in the ecosystem. So when you're setting up CI for yourself, you're going to need to try to decide a few different things. For example, which of those tools do you want to use, if any? Of course, you can always roll your own as well. You're also going to need to know which provider you're on. Not every CI tool supports every Git forge, so you actually would potentially want to consider moving your repo to one that is better supported by the CI tool, but not if you've got a lot of issues and everything going on. So anyway, that's one thing to take into account when you're picking a provider. Then the Flake support is pretty good nowadays, but there is usually a different way to do things for the Flakes or non-Flakes way. So, release.nix is the main way traditionally before Flakes came around, and now there's a lot of support for Flakes in all these different tools, but this is another decision that you want to make fairly early on when you're doing your CI deployment. Probably Flakes is the more modern way to do things. And so then, you're going to want to choose one of each of these tools to make sure that you've got something that lines it up. So that's basically all the talking I'm going to be doing here. I do want to ask, how many people in this room already are running some sort of CI integration that they manage on a repo of theirs? Okay, great. So that looks like about 40% of the people in the room. So great, you all just volunteered. So how many people have a project that needs CI but doesn't currently have it? I think probably there are a few people who should have put their hands up and didn't, but anyway, all of you are the ones who we're really here to help today. So we want to make sure that by the time everybody leaves here, everything they've got is being CI'd. At the very least, everything should be getting built. Ideally, you have a workflow that includes, green check marks and red X's for all of your pull requests and merge requests and things like that. And hopefully you are populating a cache, and if you are working with other people on a team, you've given them instructions for setting up the cache so that When you push some massive change in your merge request, they don't have to take 4 hours to build it before they can test it. Similarly, with continuous deployment, that's something you might want to consider. Even if you've got CI set up, maybe you don't have CD set up, that's something that we can also help with. And basically, I want to encourage people to ask as many questions as possible. We're going to have people wandering around. Everybody who knows me here better be doing that. And so, we're just going to try to help out, answer questions. If there are questions that seem like very generally relevant, I might turn on the mic and announce them or something. But I think for the most part, it's going to be about like, how do we get through each person's individual issues with their repo? How do you, because there are various situations you can run into where the CI won't work as well as it might otherwise. And hopefully, everybody leaves with something that's working and running. So before we break into that, are there any questions? There?
Yeah, question about CIs. You mentioned a bunch of different feature columns or whatever you had in that slide.
Yeah.
One other feature that I wonder about is whether you can have a way to download things more quickly. Like, a lot of these solutions have problems where you're spending a lot of time downloading from your cache before you start doing your CI job. You have dependencies.
Right. Yeah, I would say all of these do a considerably better job with that than just like typical, like, for example, if you go on GitHub or GitLab and you just use one of their standard runners and say Nix build this thing, then almost all of your CI time is going to be dominated by downloading dependencies every single time. And then you can get kind of fancy and try to shove that stuff into their cache and pull it out. It's sort of a mess. These tools, because they're Nix focused from the beginning, they are designed to do that better. And typically they will have, if you're running on a cluster, ultimately things will need to be downloaded and moved around sometimes, but these tools are gonna get it pretty nice from the get-go. You're not going to have nearly the amount of downloading and uploading time and that kind of stuff. For example, with Hercules, I think most of the users of Hercules are going to have one or several large builder machines, and those machines are just always going to have most of the stuff in their local cache. So that works super nicely. I think Garnix has something sort of internal to their cloud that does a similar thing. I don't know the details of how Hydra works, but it works at the scale of all of Nix packages built multiple times a day. So it's getting that right too. So that is one of the big reasons that it's better to use a Nix specific CI than to just use a typical average, sort of mainstream CI. Go ahead.
On the topic of mainstream CI, theoretically, if you were on a team that had a very mature CI/CD platform using the tools from our friends at Atlassian, and maybe you have team members who aren't really convinced that this Nix thing is something you need, I guess two questions, how would you convince your team that that is something that's worth moving to? And the second part of that would be how would you approach then moving off of that legacy CI/CD framework to something like this?
So in terms of convincing people, usually people who are operating CI systems, which often falls under the DevOps category, care a lot about speed. So I've heard one of my clients, for example, they have a KPI for, are the CI/CD builds under 5 minutes? So that's something that's got management visibility for them. So I think that just bringing those speeds down, because really with a Nix-focused tool, you can beat the pants off the speed of traditional CI tools. You can get down to the point where it's very little changed, so all I'm actually doing is evaluating the Nix expression, which might be seconds or tens of seconds, as opposed to traditional CI. Even if it's got caching and stuff, it's usually going to relink, or it's going to at least do something bigger than that. And then in terms of the actual operation of transitioning, I think it depends a lot on how the existing CI system is set up. But for example, on GitLab, so GitLab allows you to specify a directed acyclic graph of jobs in their GitLab CI.yaml file. And what you could effectively try to do in that is you could say, well, my Nix-specific CI is going to be one of the nodes in that graph. And then I'm going to make everything that might want to pull from that cache be a dependency, or be a dependent of that node. And then you can make sure that everything's in the cache before, maybe some third-party tool wants to, I don't know, run a virus checker or something, right? And so then it can always deterministically pull from the Nix cache because it's afterwards in the CI pipeline. Yeah. Go ahead.
Would you approach other like smoke tests, integration tests, deployments, things that are not strictly building Nix expression, things like that? Would you approach that the same way?
For the most part, yes. Although I think that there's a pattern that I've come across in the Nix community that can be very nice, which is to have a derivation that builds a script to do something. So for example, at our company, we produce iOS apps a lot of the time, and that can't be done. The final signing step can't be done inside of the Nix sandbox. And so we just return a bash script. And then I think the bash script invokes Nix again. So it's sort of like a continuation passing style via bash scripts for the things that can't be sandboxed and pure. So that's the kind of thing you can do, right? So you could produce an artifact from the Nix CI tool that then becomes, embodies a lot of the logic of some other step that needs to happen, even though that's an impure step. And Hercules, for example, has a way of specifying impure steps to do after your build successfully completes in the Nix language. So you can kind of do what I was just describing. You can produce a script and you can say, whenever the master or main branch, successfully finishes building, then run this script, which maybe is a deployment script or something like that. It tends to be very specific to your CI system, how you do anything like that, but I think it's great to integrate it with Nix. I think that Nix doesn't have a lot to say about the very final impure step, but it can produce that step for you, and that can be a really useful way to do it. Yep. Go ahead. Well, I think I've seen a lot of projects that involve integrating Nix with Bazel and or Buck. I think that can be a little bit awkward. Obviously, those systems do have advantages in some areas, and I think also disadvantages in other areas. I think the key with Nix to structuring those kinds of like code quality tests and other kinds of tests is to leverage the fact that it's a directed acyclic graph, right? Try to get as much parallelism as you can. So there's no reason you can't invoke a Bazel build inside of Nix, right? Or invoke some other tool. And there's no rule that like the output of your Nix expression needs to be a package, right? So for example, you could, I don't want to get too specific about particular tools, but like, let's say you had a code coverage tool that produces some sort of report at the end, right? So you could write a very small Nix expression that says, hey, take my source directory, take the tool, run the tool on the source directory, and then just whatever its output report file is, copy that to $out, right? And that's my output. And so now you've got this artifact produced by the Nix system that has that report. Or you could even go a step further and say, well, the report had better be all good Otherwise, I fail as a build. So I think, if you look at Haskell.nix, which is it's IOG's sort of next generation proposed Haskell infrastructure for Nix, it takes every Haskell package and splits it into a library component, a test component, various other benchmark components, things like that. And each of those is a separate Nix derivation, which means that if you have a library that depends on another library, it can start building before the tests finish running for the first one. So I think that's a very valuable technique as well. Just because something is one package doesn't mean it needs to translate into one Nix derivation. It can be a DAG of Nix derivations that come together at the end, and then you can leverage a bunch of parallelism in the Nix build, as well as avoiding rerunning things that haven't changed.
Yeah, please.
Yeah, just a small addendum there. Historically, with Nix packages, Hydra is going to take a while before it even starts to evaluate. We haven't really thought about latency so much, but I think some of the idea with this AI use case is if we are going to run something every commit or every PR, we do care about these issues, and we're going to care about them more than we traditionally have. And the good news is, just as Ryan says, Nix is ultimately just an acyclic graph of jobs. There's no rules about how fine-grained or coarse-grained those jobs have to be. And so just naturally in trying to tune our CI to be faster and faster, we're going to end up having more and more fine-grained steps and push the CI system harder and harder. And like Ryan said earlier, yes, that will take some engineering to make sure the intermediate artifacts are efficiently moving between the runners and whatnot, but ultimately we'll get to the place where Nix really is competing head-to-head with the Bucks and Basils in the world much more than it is today. So yeah, I guess I would just invite everyone to have faith that we can, if we care about this use case, we can start using Nix in ways we haven't really as a community done yet, and the technology will rise to meet the challenge.
Yeah, definitely. Is that ATTIC? Okay, cool. So yeah, I guess that should go on the list of things people should consider here. Any other questions? All right, go ahead. Yeah, I think, well, actually, in terms of free open source options, I would throw that one back to the crowd. I know Hercules and Garnix both support Flakes. Do you know if any of the other ones?
I thought Hydra supported Flakes.
There is no way in
Yeah, I think I know that Hercules has a capability to do something like that. I think it's $29 a month. So outside, for a hobby project, that's probably a bit much. For an enterprise, it's probably not such a big deal. But yeah, no, it would be certainly nice if Hydra had that capability as well. Maybe someone will contribute that functionality. Go ahead.
Just for clarity, Hydra supports flags with the Hydra jobs out.
Right. Okay. That makes sense. Yeah. Did I see another question? Okay. Well, then let's get into it to make sure that everybody who is interested in getting their CI rolling right now has the chance to do so and has the support. If you are doing that and you have a question, please raise your hand at any time. We'll be looking for hands up. And yeah, ask questions early, ask them often. Don't worry about anything being dumb, like we've all forgotten semicolons, and the second set of eyes always helps with that kind of thing. So yeah, let's get to it. And anybody in the audience who's willing to help, please help the people around you, or just start walking around and looking for hands. Thanks.